Hello. All right, guys. Now we're doing the next section of this week, which was, again, a pretty easy week. This is graphing exponential functions. Last section was solving them or using the functions. Basically, they gave you an equation, you figured out how to make a t-chart out of it, or a table. Now you're going to be graphing that table. It's really easy. It's the next step, okay? So I'm going to work through the two examples from the textbook and just kind of walk you through step by step how to get them, so you have me explaining it instead of the textbook. Okay, so the first one they give you the function y equals 3 to the x. All right, and they want you to graph this. So first step in graphing this, and look, I have no fancy graph paper. You don't need any fancy graph paper. It helps, but you don't need it, especially with exponential, because they get really big really fast, which you will see. Okay, so y equals 3 to the x. So I'm going to set up my table. We got x. We have our y equals 3 to the x column, and then we have our y column, and then I am going to make a x, y column, which is the coordinate points, right? And so on this one, I get to pick the points. They picked the same points I would use. Let's change colors. Let's change to, oh no, you know what, use the regular colors for this. 0, 1, 2, 3, right? Now we'll start switching colors. Okay, so if you remember from last section, all I'm doing is replacing this x with this number. So I'm going to say 3 to the 0. Okay, I'm going to go down the column and then we'll work our way over. So now I'm going to replace this x up here with a 1. So this would be 3 to the 1. I'm going to continue. 3 to the x becomes 3 to the 2. Right? And then down here, the last one, 3 to the x. X is now 3, so 3 to the 3. All right. Again, it's pretty easy. You're just plugging a number in. And here's where we do the math part of it. 3 to the 0. If you remember, anything to the 0 power, doesn't matter what that number is, anything to the 0 power is always 1. Then we go here, 3 to the 1. Remember, this is just saying 3 one time. What is 3 by itself? Well, that number is 3. This is 3 two times. So I would say 3 times 3. What's 3 times 3? 9. This one is 3 three times. So 3 times 3 times 3. So remember, this was 9, which means this is 27. 3 to the third power, 27. Oh, they do the fourth too. All right, I got room. We can squeeze it in there. So we got fourth. 3 to the fourth, or sorry, 3 to the x to the fourth power. This is just 3 to the 4. Okay? And so remember, this is 3 times 3 times 3. Now to the fourth would be times 3. 3 times 3 times 3. 27 times 3 is going to be 81. Okay? So we got 81. Now we have all of our points. I'm going to write them all down as coordinates. So this is going to be 0, 1, 1, 3, 2, 9, 3, 27, and 4, 81. Okay, that you should already have been able to do, because that's what we did yesterday in 10.9. I'm going to move this over to the side a little bit so you can see the points, and I can give myself room to graph it over here. Let's get my fine points. This will probably work better for this. Okay. So first thing I'm going to do is draw an axis. Doesn't need to be fancy, but let it make sense. So what I mean by make sense is, if I look at my x values, none of them are negative, right? If I look at my y values, none of them are negative. So I don't really need to go crazy on the negative x side and the negative y side. Everything is here in this positive quadrant, okay? If you want to just do a regular coordinate grid, that's fine too. Again, whatever works for you. Okay, so my x value is 0, 1, okay? Oh, that's 1, not 0. So here's 0. Let's get another color. We'll do blue, 0, 1. So there's my first dot right there. My next point is at 1, 3. So that's 1, 2, 3. So my next dot is right there. Then my next one is going to be 2. That's 3, 4, 5, 6, 7, 8, 9. I'll do green. Okay, there's 3 dots. The next one is going to be 3. You're probably starting to see the problem here. 27. So it's going to be 9, 10, 11, 12, 13. I ran out of room. It's going to be way up here somewhere. So that means 27 is only going to go over a little bit, but it's going to go up real high. So it's like way up there. And then the next one is 81. It's going to go up even higher. So it would be like way up here. And this is what is called an exponential curve because it starts out really low and gets really high really fast. Okay? Because every time this number is moving up, but it's moving up by a certain amount. It's getting multiplied by 3. So it starts at 1, then that's times 3. Then it moves up times 3 again. Then it moves up times 3 again. Then it moves up times 3 again. So it gets up really fast. So now normally, in this case, I usually, the example I always give for exponential growth is zombies, okay? Because you start out with 1 zombie. It bites 3 people. Then you have 3 zombies. Those 3 zombies bite 3 people. Then you have 9 zombies. Those 9 zombies bite 3 people. 37, etc., etc., etc. And you end up with a lot of zombies. Unfortunately, right now, we have a really, really good real-world example of exponential growth, and that's the coronavirus. Like, it starts out, we had like 1 or 2 cases, then we had 4 or 5, then we had 6 or 7, and nobody was really worrying, but it gets bigger, and it's going to get bigger. It'll level off, because that's what these things always do. The math is there behind it. But yeah, it's exponential growth, which is why people are telling you to not come to school, because we're trying to get this curve to level off as quick as possible so that everybody's safe. Anyways, enough of that fun topic. Let's move on to the next problem. Okay. Oh, and real fast, this line, if you notice my graph's not super exact, I don't care as much about the graph. Your numbers need to be right. Your graph needs to look generally correct. But these are really hard to graph because when you're starting, you look, I made these dashes. I had no idea I was going to be all the way at 81. I don't know about you, but I do not want to make 81 little marks to go all the way up here. No. Do your best. Guesstimate. Have it look about right. Okay? Let's move on to the next one, and then we're almost done. Okay. The next one, we start with y equals 10 to the x. Y equals 10 to the x. So I'm going to set up a table just like we just did. Exact same. We're going to say x. We're going to say 10 to the x. We're going to say y. And then we're going to say, right, xy, our coordinate point. Okay? For our x's, we get to pick them. So as always, pick the good old standards. 0, 1, 2, 3. Do they do 4? They go all the way to 4. 4. Okay? Easy peasy. All right? Now all these are going to have 10 to some number. That number is this guy. So this is going to be 10 to the 0. What is 10 to the 0? What is any number to the 0? Any number to the 0 is always 1. Okay? So now my coordinate point for this is going to be my x value and my y value. It's going to be 0, 1. All right? You know what? We're just going to graph all of this all at once. Okay, so our first number is 0, 1. So we'll put a dot right here at 0, 1. Right down there at the bottom. All right, let's go to the next number, next row. Now we're going to do 10 to the 1. 10 to the 1, right? What's 10 to the 1? Well, that's 10 one time. So 10. Our point, x value, y value. 1, 10. Okay, so now I'm going to plot that. We're going to go to 1. And we'll say this is 10. Sure, 10. Oh, my bad. That's 10. There's our point. Okay. See, you know what? I'm already looking at it. I made that way too high. Let's cross that out. Let's make this 10. Okay. All right. Next number is 10 to the 2. So this is 10 to the 2. 10 to that power. Okay. Right here, we're going to say, well, what is 10 to the 2? That is 10 times 10. The nice thing with 10s is you just count the zeros. So this is a 10 with 2 zeros. So 100. And look, now this is just going to be 2, 100. So I'll make a dash for 2. And if this is 1 and this is 10, 100 would be like, I don't know, we'll say here. Sure. Again, a lot of guesswork. They're all going to look about the same. All right, on to the third one. 10 to the third. All right, 10 to the third is what? Well, 10 times 10 times 10. How many zeros are there? 1, 2, 3. That means this is going to be 1, 2, 3 zeros. 3 to the 1,000. So I'm going to make a line for a 3. We'll say this is 1, this is 10, this is 100. Sure. That's 1,000. Okay. The main thing you notice is that each time the gap going up is a little higher. But left to right, it's supposed to be about the same. We're on our last one. Last one. So this is 10 to this exponent, so 10 to the 4. So 10 times 10 times 10 times 10. Again, count the zeros. 1, 2, 3, 4 zeros. So this is 1, 2, 3, 4. 4 zeros. 10 to the 10,000. So this is going to be 4 to the 10,000. 4 to the 10,000. Okay? 4, that's 1,000. 10,000 would be like way up here. We'll say like right there. Okay, so there's our exponential graph. And again, it starts out slow. It just keeps going up faster and faster and faster. That's it. That is this section. You have now done 2 sections of homework for this week. That's all I got to do. Pretty easy stuff. There's only 3 problems on this one, and then you have your worksheet packet. This is all it is. You guys can do it. All right, stay healthy at home, guys. I will talk to you again next week.